Hi, hey everyone. We are presenting the Bio-Agentic Lab Assistant. Our goal is to solve a major bottleneck in clinical research, the manual processing of complex multivariable data. Most exciting tools analyzed by drivers in isolation by biological systems don't work that way. We built an agentic assistant that interprets protocols and suggests variations while ensuring that scientists always remains the final decision maker. Okay. Uh, our architecture is that our solution handles structured data and users prompts through a robust backend, as shown in our architecture diagram. The input layers fits into Azure ML where we execute a full pipeline. We don't rely solely on the LLM's internal knowledge. We integrate with scientific RAG using a semantic scholarship API. Also, we prove feedback and insights from the scientific. Finally, when thinking through our approach, we prioritize production grade over prototype. We use several resources from Azure for data ingestions, MLOps, and governance. We also know that AI pillar is the safety design, and we implement a pre-LM safety layer via Azure Content Safety that block requests and controlled the interaction with the users. A key learning from this project was the importance of users' personal scientists and ML engineers speak different language. This led dual perspective interface, a scientific view for plain language and literature, and a technical view. In conclusion, the Bio-Agentic Lab Assistant shows how Azure AI can accelerate discovery safely and transparently. We are ready to empower the next generations of labs. Thank you.
6 steps from experiment, data, agent, search results, and monitor. And also we have some views that are the researcher and technical ones. Also we have like a semaphore from safety that it's included on the LM calls. Uh, we try to cover all the workflow from the MLOps flow since we are looking to help the researchers. Uh, we have this tab that it's from experiments, so they can upload some data. In this case, you can upload the diabetes CSV. We can see some information from them. For example, the total rows, some rows that are in quarantine because uh, they have some data that it's not like is so suspicious, maybe for because they're out of range or something like that. Um, Based on this information, you can have a percentage of valid data. Also, you have like a brief comment, and this came a summary with the null rates. Also, we have more information about the quarantine data from what columns are there, what kind of interquartile rule we are using, how many rows are affected, the lower ones and the upper ones. For example, there are some ages that are like minus 17 that it's like not realistic. And we can see some data of our data set, some of them that are in quarantine. Also, we can see some potential ID columns that are based on how many different variables we have, and also some feature columns that are suggested from the AI. And we can choose our outcome, that it's the target one, and we can choose the EDA to make the analyze. In this case, we will look for the balance of our outcome. In the case of diabetic, we can see that there are more zeros than ones, and we can show this in percentages also. Also, we can see the missingness in every feature that we have. Also, we can see the distribution for every data, and we can change the bins from this. Also, the Y column, and yeah, we can play with this. And also, we have a box plot when we can see the distribution of our data. And after we saw this data quality and structure tab, we can start training our MLOps. So in this case, we choose our target, that is diabetic. We can choose like what kind of ID are. In this case, it's just patient ID. So we can start training our model. So we send a SureML job, and in this case, it's looking for the best model that we can have. Start preparing. Now it's queued. Some things that maybe we can are trying to look, since we are training our dataset. We can show here in agent, like we can give them context about what we are looking, and also we can ask questions. What's diabetes, for example? That's a simple question, but how but this has an LLM, so it can answer those questions and also give us like uh, what is the reasoning that it has. Also, we can look for search, so we can look for keywords, and they can give us uh, like an insight from the AI. They can recommend us about, for example, similar in paper one, aligning set enrichment analysis, useful if you later integrate genomic data to explore molecular pathways. So this recommend us data sets and papers. So for example, in this case, we have 10 papers that we can look to include in our research, and also we can include some data sets that we can use in our training. Finish, we can see the evaluation summary, and we can see that we dropped the patient ID. This is a classification task, and the GBRT algorithm was the one who reached better metrics. In this case, the AUC was better in this case than the logreg and RF. So since we just train, evaluate, we are now in the last step, that it's deploy. We can deploy our model, and now it's registering in our Azure instance, and we can just here in the last step, that is monitor, we can have the endpoint that right now it's in local because we are just deploying. Since, and also right now we are not seeing drift, but in the case we are continuing giving more data, we can look if how is the data changing in the in this time context, and also with new data, and if they recommend us retraining our data. And in this case, we have a brief comment with some alerts, and we can take an evaluation drift. And this is for all about our demo.